Hello everyone, this is Mrs. Figueroa. Today we're going to be going over factoring binomials of higher degree. So our objective, students will be able to factor binomials of higher degree. This should be familiar to Math 2. The only difference for Math 3 is we're looking at higher degree polynomials. So if we look at the prior knowledge, you should be able to factor the binomial. And if you recall to your Math 2 class, you should know how to do this. So this is called the difference of two squares. So difference of two squares. And I like to abbreviate this for my students as dots, D-O-T-S. And you'll hear me reference dots throughout this video. So I'll say, don't forget to check for dots. This is what I mean for a difference of two squares. So the rule kind of for a difference of two squares is if you have a squared minus b squared, is to factor it, you'll do a plus b and a minus b. So if you notice for this example, we got x squared minus 25. So if I were to factor this, my a value, the first term, a squared, I take the square root of it, and that'll give me the a value. So if I take this x squared, it's going to be x and x, and I'm going to have a plus and a minus. It doesn't matter if you put the plus or the minus first. I don't have a preference, but maybe one of your Math 3 teachers does have a preference if you do the minus before the plus. To me, it doesn't make a difference. Anyway, so then the next term is a b squared. So you take the b value, which means you take the square root. So square root of 25 would give you 5. So the difference of two squares in factored form would end up being x plus 5, x minus 5. And that would be your final answer since you're not able to do anything else to them. And again, this should have been something you guys learned in Math 2. So now let's look over more of a Math 3 example. So now we're going to factor each binomial completely, and if the binomial cannot be factored, we just write prime. So the steps kind of to follow is the first one you always want to check for your GCF. If it has a GCF, you want to factor it out, meaning greatest common factor, if there is one. And then if the binomial has a difference of two squares, you want to factor it into two binomial factors and then repeat this step as necessary. So if I look back at this example, 9 and 16 don't have anything in common, so I don't have a GCF there, but I do notice that both of the terms have an x to them. So then I can take out the greatest common factor. The greatest thing they have in common is the 1x. So I can factor out an x, it's my GCF, and then that would reduce my exponent. So x cubed would then become x squared. So this becomes 9x squared minus 16. And I've factored out the x, so it goes away. And then, so I have step 1 is complete. Step 2 is you're checking for difference of two squares. You're checking for dots. And remember, it's a squared minus b squared. In order for be a difference of two squared, the word difference means subtraction. So you need to have a subtraction symbol, and then you need to have two perfect squares. So 9 is a perfect squared, and x squared is a perfect squared, and then 16 is also a perfect squared. So if you remember your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. So I see 9 and 16 are both on my perfect squares. So I know this is a difference of two squares. So I'm going to use my rule, a plus b, a minus b, and it's you're taking the square root of the term. So if I take the square root of 9x squared, square root of 9 would give me 3, and then x squared cancels out, the squared cancels out the square root, so you just get x left over. And then your b value, take the square root of 16, is 4. So I get my 4 on my second spot. And then I need one that has a plus, and the other one needs to have a subtraction. So it's the term a plus b, a minus b. That's your rule for difference of two squares. And then repeat the step as necessary. If you notice I can't do anything inside the parentheses, I no longer have a difference of 2 squares. So this would be your final answer. Okay? All right, moving on to the next example. One more time, you want to check for your GCF. So check, well, I see a 3 and a 27. I know 3 goes into 27, so I'm going to take out a 3. And then I also see that they have an x in common. So the biggest thing I can take out is an x. That's the greatest common factor that they have in common, okay? So if I take 3x cubed and I divide it by 3x, because it's a factor, so I'm dividing it out, my 3 would go away, and then I took out 1x, so I'm going to be left with x squared. Again, I factored out the 3, so it goes away. Minus 27 divided by 3 is going to give you 9, and then your x goes away because I took it out. X divided by x is just 1. And then you want to check for dots, difference of 2 squares. Do you have a difference? I have a subtraction, okay? Then I want to see, do I have 2 squares? X squared is a perfect square, and 9 is also a perfect square. So I can use my difference of 2 squares to factor it out. So I take the square root of x squared, which is just going to be x, and then the square root of 9, which is going to be 3, and then I need an addition and I need a subtraction. And then repeat as necessary. Can I do this again inside the parentheses? I no longer have like in this second term, I no longer have a difference. And my last term, I have a difference, but I don't have perfect squares. So that tells you you are done. And that's your final answer. Okay. Next example. These are all just basically a whole bunch of different examples for you guys. Okay. So again, first you want to check for GCF. Do you have a GCF? Does 2 go into 18? Are they common factors? Yes. I have a 2 I can take out. And then notice this has x to the 4th, x squared. So the biggest thing they have in common is an x squared. They don't have an x to the 4th in common because x squared only has 2 of them. So the biggest thing you can take out is an x squared. And then to figure out what goes inside the parentheses, it's like you're dividing. So 2x to the 4th divided by 2x squared. The 2's would cancel. Whoops, sorry. The 2's would cancel. And then the x to the 4th divided by x squared, the rule is to subtract the exponents. So 4 minus 2 would give you 2. So x to the 2nd power. And then if you do, you still have the negative. So I'm going to copy the negative. And then 18x squared divided by 2x squared. Exponents here, they would end up canceling. X squared divided by x squared is going to be 1, and then 18 divided by 2 is going to give you 9. Okay. If that's kind of confusing, I apologize. That's just a different way of explaining. That's basically how you end up with the things that are inside the parentheses. You just have to figure out what is it you're taking out and then divide the terms, the original terms, and that's what you end up with in the parentheses. Okay? All right, anyways, sorry about my explanation if it was confusing. Then you have to check for dots. Difference of 2 squares. Do you have a difference? Yes, you have a subtraction. Do you have 2 perfect squares? I have x squared and a 9. Those are perfect squares. So I can factor that out. I'm going to end up with 2x squared. Take the square root of x squared is going to be x. Take the square root of 9 is going to be 3. And then you need an addition and a subtraction. And then check for dots again. I no longer have a difference of 2 squares, so that is your final answer. All right, next one, x squared plus 36. You want to check, do you have a GCF? I have an x squared, I don't have a number in the front, and then I have a 36. I don't have a variable. I don't have anything they have in common, so there is no GCF. Okay, then you want to check, do you have your dots? Is there a difference of 2 squares? The D stands for, remember, difference. This is an addition symbol, so there is no difference of two squares. I don't have a difference, so I can't do anything. I can't take out a GCF, and I don't have a difference of two squares, so if I can't do anything, my answer is going to be prime here. Okay? All right, next example. We have 5x squared plus 20. It's the same thing. You want to check for GCF. Do they have something in common? I have a 5 and I have a 20. 5 goes into 20, so that's a common factor. You want to take out their 5. They don't have any x's in common, so the only thing you can take out is 5. So 5x squared divided by 5 is just going to leave you with x squared. And then I have my plus. 20 divided by 5 is going to give me 4. And then I want to check for my dots again. Difference of two squares. So one more time. D stands for difference. Difference means subtraction. I have an addition symbol in between, so I don't have a difference of two squares. So I can't do step 2. You would not say that this is prime because you took out a GCF of 5. You were able to factor it by taking out a GCF of 5. So we do not write prime in this example. That is your final answer. 5x squared plus 4. Okay? Again, the answer is not prime because we had a GCF of 5. Okay, this one is a practice problem, so I want you guys to pause the video and then practice this example, and then I'll show you the solution in a second. Okay, hopefully you guys paused the video. So here's the solution. You have a GCF of 2x. So 2x cubed divided by 2x will give you x squared. And then 98x divided by 2x is going to leave you with 49. And then this is a difference of 2 squared because you have a subtraction and you have two perfect squares. So you take the square root of each of them. Square root of x squared gives you x, and square root of 49 gives you 7. And then you add an addition and a subtraction symbol for that one. Okay? I am going to... Did I skip a whole bunch? Okay. I am going to possibly just skip these, and then your teacher will most likely go over more examples during our Zoom sessions. Okay? Sorry, those were a lot of examples. Let's look at this next example. I believe this is in your guided notes. So the directions again, factor each binomial completely. And if the binomial cannot be factored, we're going to write prime. So remember our steps. First, you want to check for your GCF. So my GCF, do I have a constant in common? Do I have a number in the front? I have an x to the 5th. And I'm minus 81x. What do they have in common? I see this has an x and an x. So the biggest thing I can take out is an x. That's going to be my GCF. And if I take out an x, what am I left with? So x to the 5th divided by x. I'm taking out an x, so I'm left with x to the 4th. Sorry, that doesn't look like an exponent, so let me erase that. I wrote my 4 too big. That's x to the 4th minus 81x. I took out an x, so I'm just left with 81. And then I want to check for a difference of two squares. So I have, again, my perfect squares are 1, 4, 9, 16, 25, 36. That's 6. 7 squared is 49. 8 squared is 64, 9 squared is 81, and 10 squared is 100. So you want to check on this list, do you have that perfect square? So 81 is a perfect square, it's on my list. And then my x to the 4th, the x's are kind of just different just because when you take the square root, basically if the exponent is positive, even, sorry, if your exponent is even, it is a perfect square, okay? So x to the fourth is going to be a perfect square, and you have 81 is on the list of perfect squares, and we have a subtraction, so it's a difference. So I do have a difference of 2 squares. My dots, difference of 2 squares, I am going to split this up. Okay, so then my x to the fourth, if I take the square root of that, x to the fourth split evenly would be x squared, okay? And if you think about that, it's because if you multiply that, x squared times x squared, the rule for multiplying is to add the exponents if you have the same base. So 2 plus 2 would give you 4, okay? All right, anyways, and then the square root of 81 is going to give you 9, and then we're going to add and subtract, okay? So plus or minus. Notice this time though, I do have x squareds again. So you want to repeat as necessary. So now you want to check for dots again. So we got to repeat. Check for dots. My second term, I have an addition symbol that is not a difference. So that's not a difference of 2 squares. But my third one, I do have a subtraction symbol. So my subtraction symbol is a difference. X squared is a perfect square, and then 9 is also on my list, so this is a difference of 2 squares, so you can still factor that out. So we have x squared plus 9, and then my x squared minus 9, I am going to have to factor that out into 2 binomials. So square root of x squared is going to give you x, and square root of 9 is going to be 3, and then we're going to have a plus and a minus in between. Okay, I personally don't have a preference. You can leave your answer like that, but I'm not sure if some of your math 3 teachers are going to ask you to rewrite it like this. So x plus 3, x minus 3, x squared plus 9, and that's going to be your answer. Like I said, if you're in my class, I don't have a preference. You can rewrite it where you have your x squared at the end, or you can just leave it as is. I personally don't have a preference, but some of your math 3 teachers might like you guys to have a specific order. So talk to your specific teacher and see what they like. Okay, I believe this is my last example. So for each binomial, factor each binomial completely, and if it can't be factored, write prime. So one more time. First, check GCF. I have an x. So I have a GCF of x. All right. Then you want to see 4x to the 5th divided by x. That's going to give you 4x to the 4th power, because I removed one of the x's, minus x divided by x is going to be 1. And then that looks kind of funky to some people, but remember, you're checking difference of 2 squares. D stands for difference. I do have a subtraction. So then I have to check, are my terms of perfect squares? So my perfect squares are 1, 4, 9, 16, ... Okay. So I do have my 1 on the list, and I have the 4 on the list, and I also have an x to the 4th power. And that exponent is even, so it is a perfect square, okay? Which means I do have dots here. I do have a difference of 2 squares. So I'm going to split this into 2 binomials. And if I take the square root of this, square root of 4 is 2. And then x to the 4th, square root of x to the 4th is x squared. Okay? So this is going to be 2x squared. And then square root of 1, sorry guys. I clicked on my email on accident. Okay, so square root of 1, some people have issues sometimes recognizing the 1. So square root of 1 is 1. And then you need a plus and a minus. And then you have squares, so you want to check to see if you have difference of 2 squares again. So let's check this. My second term is an addition, so no difference there. My third one, I do have a subtraction. However, I have a 2x squared is 2 on my list over here for difference of two squares. Sorry, my list of perfect squares. 2 is not on the list, so then 2 is not a perfect square. Even though x squared is even, 2 is not a perfect square, so then this is not a difference of two squares, and that is actually your final answer. Okay? All right, I'll do a practice problem, and then that's most likely where we're going to end off. Okay? Go ahead and pause the video and try this example on your own. All right, so here's the solution for you guys. Hopefully you paused the video and tried it on your own. This one had a GCF of x, and then you want to check for difference of two squares. That is a subtraction. 16 and 9 are both perfect squares, and you have x to the fourth, which is even. So that tells you that it is a difference of two squares. And then if you were to take the square root of 16x to the fourth, you get 4x squared. And the square root of 9 gives you 3, and you add an addition and a subtraction between those, and that's your final answer. Okay? All right. I'm going to stop there. All the other examples, your teachers will most likely just use the Zoom meeting to go over them. Okay? Thank you guys for joining me, and remember to complete your homework assignment and submit it.